Welcome to part one of our lecture series from Wednesday, March 22nd, where we begin to discuss this concept of an aqueous reaction. So in order to understand what's going on when I say aqueous reaction, we should probably start with a definition of what it means to be aqueous. And we have seen this definition before earlier in the beginning of the year when we were discussing classifications of matter. So remember, aqueous is a term that describes something that is in solution, specifically with water as the solvent. So it's kind of like a pseudophase, right? It's not solid, liquid, or gas, but we will often use AQ in parentheses in our chemical equations to represent when something is present in solution. Now let's remind ourselves about what's going on when we have water as a solvent, recalling that water itself is a polar solvent. So from our electrolytes lab, we know that polar solvents can dissolve polar covalent solutes and also ionic solutes or ionic compounds. And the difference between these two is that polar covalent solutes have no dissociation into solution. They retain their overall molecular form. So these are our non-electrolytes. And ionic solutes are the exact opposite. We do see full dissociation into ions in solution, which is what makes our ionic solutes strong electrolytes. And when we are talking about aqueous reactions, almost all of our reactions are going to be discussing what's happening with ion solutes, so ionic solutes, meaning that when we look at an aqueous reaction, we are going to consider reactions and interactions between B/WN, between ions in solution. Now, when we are looking at these reactions, interactions of ions in solution, let's remind ourselves about what kinds of interactions or reactions we know from just our major classes of different types of chemical reactions. So most commonly, when you are looking at aqueous reactions, you are looking at either a single displacement reaction, where in the context of what's happening with things in solution, the things that are being displaced are ions. So we would say that one ion displaces another. We are going to talk about those types of reactions quite a bit coming down later after break, down the line. And the other type of reaction that we're most commonly going to encounter in solution are double displacement reactions, where if we're thinking about again what's going on in solution, we're looking at ions displacing one another. So there's two ions displacing one another. So for example, If I were to look at a solution of ionic compound AB, and I were to mix that with a solution of ionic compound BC, let's see what we might see happen if A and B and C and D undergo a double displacement, meaning their ions displace one another. So here I have my two solutions, AB, you know what, let's call this one CD just for clarity. There we go. And if I were to recall that these are ionic solutes, that means that these fully dissociate once they are in solution. So solution containing AB is really a solution that contains A cations and B anions in a 1-to-1 ratio. I know that A is the cation because it's what's written first in our chemical formula, and B is our anion because it's what's written second. And I know that these both need to have 1-to-1 charge ratios because there's only one of each based on the subscripts in this chemical equation, or excuse me, formula. So if I had written A2B, that'd be different. I'd have two A pluses. So this is what we're looking at. And I'm going to go ahead and draw 2 units of B here, AB. And now let's also do compound CD. So when I'm looking at a solution containing compound CD, I'm looking at C cations and D anions. So if I were to look at the product beaker, which is the result of mixing each of these solutions, we would be looking at what would happen between our ions, A plus, B minus, and C plus, D minus. So remember, double displacement is where one thing displaces another and vice versa. And the way that I like to think of double displacement is I like to think about our cations swapping anions. So it's a little do-si-do, change your partner type reaction. So in my product beaker, I would be looking at potentially my B and D anions swapping with one another or displacing one another, meaning that I would maybe potentially have something with A plus and D minus if they do react, and then also something with C plus and B minus. So in this reaction beaker, I am showing the potential ion pairing that is resulting from our double displacement. And as we saw in our first experiment, or part 1 of our 9 solution problem, we know that this can be some kind of pairing that results in a bunch of different things. So what we are going to be doing next is we are going to be looking at one of those first types of possibilities by looking at what's known as precipitation reactions. So we're looking at our first double displacement aqueous reaction, what happens, known as precipitation reactions. So we'll see that in our next video coming up.